On December 15, 1960, representatives of the Air Force's Air Research and Development Command, NASA, and the Atomic Energy Commission met in Los Angeles at the predecessor of SMC, the Ballistic Missile Division. They initiated a joint effort to develop a high-altitude satellite system which could detect nuclear explosions in space and, with later versions, above ground in Earth's atmosphere. The program was known as Vela, Spanish for Watchman. Vela began as an ARPA program in 1959 under direction of President Eisenhower to enable technology for detection of nuclear tests and verification of a future nuclear test ban treaty under negotiation with the Soviet Union. Over the next decade, the Vela satellite program became the model of superior management, design, and cooperation in the Air Force's space programs. The initial Air Force budget for a 10-satellite program was $15 million. In November 1961, BMD awarded a contract to Space Technology Laboratories, later TRW, for the 10 satellites. This was the first ever performance incentive fee contract written for an Air Force satellite program. Through the course of 1961 and 1962, the Atomic Energy Commission began to develop the Vela sensor payloads at its Sandia and Los Alamos laboratories. The Vela satellites would require a unique set of sensors for its mission. Sensors which would be required to detect a signature of X-ray and gamma rays emitted by nuclear detonations and report this data to the ground. Many new technologies would be developed and readied for the Vela satellites in a short 2-year time frame, leading to its first launch in 1963. Here we see President Kennedy during a visit to Sandia Laboratories on December 7, 1962, inspecting a Vela satellite mock-up. The plan was for the first 10 satellites to be launched in pairs aboard Atlas Agena launch vehicles in 1963 and 1964. As it turned out, the first 6 were so successful, reliable, and lasting well beyond their design life that the last 4 were never launched. On August 5, 1963, the United States, England, and the Soviet Union signed the Limited Nuclear Test Ban Treaty. And after U.S. Senate ratification, it went into effect on October 10, 1963, halting all atmospheric and space detonations of nuclear weapons among the 3 nations. Here are President Kennedy's remarks on that historic day.
If this treaty fails, it will not be our doing. And even if it fails, we shall not regret that we have made this clear and honorable national commitment to the cause of man's survival. For under this treaty, we can and must still keep our vigil in defense of freedom. But this treaty need not fail. This small step toward safety can be followed by others, longer and less limited, if also harder in the taking. With our courage and understanding enlarged by this achievement, let us press onward in quest of man's essential desire for peace. As President of the United States, and with the advice and consent of the Senate, I now sign the instruments of ratification of this treaty.
Less than a week later, on October 16, 1963, at 9:37 p.m., the first pair of Vela satellites were launched from Launch Complex 13 at Cape Canaveral aboard an Atlas Agena into a circular 115,000-kilometer orbit separated 180 degrees apart. A further 2 pairs were launched July 17, 1964 and July 20, 1965. These first 6 Velas were relatively simple spin-stabilized spacecraft. In 1965, the DoD approved the Advanced Vela program, and again, TRW was contracted to build 6 advanced Vela satellites. These satellites were not spin-stabilized, but had their axes oriented toward the Earth's center, allowing onboard instruments to make even more accurate determinations of nuclear detonation characteristics. The 6 advanced Vela satellites were launched in pairs on Titan 3C launch vehicles from Cape Canaveral in 1967, 69, and 70. Once again, they lasted far beyond their design life of 6 months, with the last of the advanced Velas deliberately turned off on September 27, 1984, 15 years after launch. Besides performing its main mission of nuclear detonation detection, the advanced Vela satellites in 1967 provided a key scientific discovery. On July 2, 1967, the gamma-ray detectors aboard the fourth pair of Vela satellites recorded the first ever extraterrestrial gamma-ray burst. This discovery led to a new field of scientific investigation and the development of NASA spacecraft such as the Gamma Ray Observatory and SWIFT, whose missions were to continue the search for these cosmic events. Today, 50 years after the first Vela launch, the legacy and mission of Vela lives on through the United States Nuclear Detonation Detection Program. For the past 30 years, the GPS satellite constellation has provided worldwide coverage for nuclear detonation detection with unparalleled location and timing accuracy. Since 1970, the DSP satellites have also carried nuclear detonation detection capabilities. These platforms are not only providing our key method of monitoring the compliance of the 1963 Nuclear Test Ban Treaty, but also the necessary means of nuclear detonation detection capability for the warfighter and our National Command Authority if needed. It is thanks to the incredible success of the Vela program that today's Sentinels in space continue a key mission to our nation and the world.